Beckhoff and TwinCAT 3 is breaking that barrier between IT and AT world in ways that no other platforms are doing at this time.
Let's come to our first guest from outside. Peter, can you hear us, first of all?
Yes. Yes, loud and clear.
Oh, that's perfect. And you know what? We can hear you. So that bidirectional communication has already been established. Perfect. Welcome here on stage, on the virtual stage, and to this TwinCAT roundtable. Well, I introduced you already briefly, and I think you have built within Inxton a platform for the automation engineers to ease their life, to be able to integrate, let's say, more state-of-the-art code that might not be so easy to realize with traditional and proprietary systems. So you based that on TwinCAT. Can you tell us the reasons behind that? Why did you choose TwinCAT 3 as your software platform for your own software platform, so to speak?
Yes, thank you. It's my pleasure to be here. Thank you for having me. Yes, we were looking for some ways to develop the software for the automation in some more robust way, and we were trying out different platforms. When Beckhoff came with its TwinCAT 3 integrated into Visual Studio, we said, bingo, this is probably what we need. And since then, it was about 10 years ago, we started to develop this framework for internal use at the MTS company, which gave us the opportunity really to, so what you were saying at the beginning in your introductory note, it's true. Beckhoff and TwinCAT 3 is breaking that barrier between IT and AT world in ways that no other platforms are doing at this time. Yeah, we choose simply TwinCAT 3 because it was, so our idea was to bring together the PLC and some higher level frameworks, and that higher level frameworks is .NET. It was a natural choice since Beckhoff integrated the TwinCAT into Visual Studio. What I can say is that it was a great experience. We never regretted to start to work with Beckhoff. We invested a lot of our effort into it, and it was a great journey. What it helps us is to basically develop the applications faster. It is, I can say, it is fraction of time that we need to develop our applications on TwinCAT and with Inxton when compared to other technologies. We also put the Inxton, or the foundational libraries of Inxton are now available for any user who would like to try it out.
Well, thank you very much, Peter, for these interesting insights. So I remember the first time we met, it was, well, virtually over LinkedIn. We had a nice discussion, and later on we had a video call, and I remember you actually reporting the very same history, or the very same story, and I found that actually quite interesting and quite groundbreaking. Thank you very much for that.
Yeah.
Let's come to our next guest, Jakob. Can you hear us? First question of the day to you.
Can hear you perfectly fine.
Okay, and we can hear you perfectly fine. So here, communication established. Perfect. We're ready to go. So, Jakob, you're known as a blogger to the community, and well, you have created a blog around TwinCAT. I have a second question for you afterwards. Should you not answer that question within this question? So, well, what was the reason for you to create a blog around TwinCAT, TwinCAT 3?
Well, so the reason is, I mean, my background is standard IT development, software engineering. So I mostly used C and C++ and Java and other IT languages. And when I started with the world of automation with Beckhoff, most of the information I was looking for was available on the Beckhoff Infosys, but I missed this feeling of a community. So I didn't quite find any good community. And when you do software development and in C, C++, or .NET or whatever, you have these communities like Stack Overflow and different forums, and you have loads of open source projects. So I missed this, and I thought, okay, when I started to get some experience, I thought it would be nice to share some of this knowledge. So I decided to start this blog. And I mean, the more I worked with TwinCAT 3, the more fascinated I was, and I quickly realized, okay, this is something I want to work with for a long time to come, because stuff I've been doing previously in C and C++, I could do much faster with PLCs or with TwinCAT 3 in particular. So, I mean, this is machine builders. I mean, I realize it's mostly machine builders doing this, but software development in TwinCAT, from my perspective, doesn't necessarily need to be much more different than what we have in this classical IT software development. And I was just curious of how I could use my knowledge in standard software development in an IT world and apply it to TwinCAT. And I want to just have a blog to showcase some of these modern software practices in the world of TwinCAT and share this knowledge and the tools that I also started developing. And I think in the recent years, in the last 2 or 3 years, this has started to change, and you can actually see some blogs starting to pop up and also some open source projects, which I think is really, really nice.
Okay, thank you very much for these insights. So you're a software engineer. Your background is not really automation, is that right?
That's correct. That's correct.
Okay, so you are the perfect example, actually, how TwinCAT is able to bridge IT and AT. You see, we got a software engineer into the automation world, working for a Swedish machine builder. That's great. That's a nice story. I like that one. But Jakob, you did not answer the question that I was hoping that you would answer. That's why I'm bringing it up right now. I've read on your blog actually, that you have done software development for a telescope. Could you tell us a little more about that? Because that's actually quite a cool story.
Yeah, that's actually the most interesting and the most exciting project I worked with. It's the ELT, the Extremely Large Telescope. I know they have a really good naming. I mean, the previous telescope was the VLT, the Very Large Telescope. This is the Extremely Large Telescope. The naming is just fantastic. And this is the one being built in Chile. And most of the software that's used in this telescope is from this classical IT software development that I was talking about. So it's based on real-time Linux, and you have software written in all these standard languages like C++, Java, Python, and lots of different scripts. They have all these modern software development tools. And the people that was working in this project that didn't work with PLCs, they always looked at PLCs like this ancient old school technology where you have to use an USB stick and put it inside the PLC to update the software. And it's just and I can't blame them, because I mean, a lot of these other brands, I won't mention any, when you look at them, it just looks really ancient. But so when you got into this team of these software developers, you just noticed we just got more and more software to build in the telescope using TwinCAT. And that's when we realized, okay, maybe we should modernize the software development tools for this as well. So what we wanted to achieve is to build and deploy software the same way we did for the other, for this Linux parts, so the C++ software. So we actually set up a complete tool chain using Jenkins, something called this continuous integration, continuous delivery tool chain, where we could just build and test software and deliver it automatically all the time. So in this telescope, again, we have over 100 PLCs. I think it's close to 200 TwinCAT 3 PLCs in the telescope. And when you get into the size of a project like this big, then you really need to automate more of the software development. And I mean, I like to compare this to, Beckhoff, they have used a decade or decades of PC development to their advantage. I mean, you have really powerful PLCs, right? And I think we should use the same thinking about this, but with the IT development. I mean, the IT software development practices have really gotten really far. And I wish and I hope and I want the PLC software development to look more into this as well and utilize all of this development in TwinCAT 3 development. And I think, and this is completely possible today. I mean, parts of this, Beckhoff have released software which makes this possible, like the TwinCAT automation interface, and you have recently released the static code analysis tool. And we just needed to add a little bit more, like this unit testing framework, this TC unit that you might have heard of. But together with this, we could basically do the same thing as you do in other development environments like C or C++. And I just think it's just an exciting field to be part of, and just that's why I want to put this out on my blog, just to see, yeah, you could do it the old way, but there are alternatives.
Okay, thank you very much for these insights and this feedback. That's yeah, very interesting, Jakob. Thank you. I'd like to get back to Peter quickly because, well, what you just mentioned, Jakob, was, of course, you would like as well, you know, the IT community and the automation community to, let's say, do more quality testing, etc. And we see that there are, in terms of developing automation software, there are more and more commonalities between developing standard software and developing automation software. You have to ensure that the code is correct, etc. There are many collaboration possibilities. That's why when we look into modern projects, Peter, question for you. There are more and more specialties being required, and more specialties, or, well, people with specific specialties, so to speak, that are involved in the projects. And they have to work together, they have to collaborate. How do you do that at Inxton?
Okay, so once your project gets big, so one of the ways how to make the software development faster and more reliable and more fail-proof is to create well-crafted libraries that would give you the opportunity to reuse them in many projects. To do that, I'm completely in sync with what just Jakob said. We need to use tools that we know from the IT development, and this is specifically the continuous integration and unit testing. So at Inxton, we have basically we have set up a pipeline. Every time any of the developers delivers some piece of code that is sent into the build server, there it is tested, it is compared against, it is loaded into some older projects to see if whether we broke something or not. We are unit testing those libraries. We are doing some integration, regression testing. And with this, when we deliver the library, we are pretty sure that that library will not break something next day on some machine. I would say this is possible because TwinCAT is really an open platform, and you can integrate it with source control. That is crucial for any software development, especially when you have more people participating in the development. Then you need to have an opportunity to check in the code, to see what has changed, to see who did what and when. And this is really something that is hard to see on other platforms. Yeah, we are really grateful to Beckhoff for developing this platform, because it made our life way easier.
Okay, thank you for these insights. So we have already seen now a few aspects of why actually Beckhoff is a future-proof platform. I kind of understand that the integration into Microsoft Visual Studio was one of the more important actually milestones, and well, nice to see, Jakob. Maybe in the future, who knows what the ELT is going to discover, and if we can contribute to that, I think we'll be more than glad to do so, and exciting. Josef, now we've heard why Jakob and Peter think that it might be a future-proof platform. Let's have a glimpse into the future. Can you tell us, what can we expect from actually TwinCAT in the future? What are, let's say, the disciplines, the technologies that you see have to get into that platform to make it even more future-proof for the users out there?
Yeah, so we see more and more software coming into the automation platform. So next step for us is that we this year released Vision. So this means that we have a complete integration of Vision into TwinCAT. This means configuration is in the same tool, and of course also the programming is in the same tool, and we do the programming in PLC. So this is different to our competitors, and we see this is as a next topic based on our platform. So we can easily integrate Vision, and every PLC programmer can do the programming of a Vision application. And next step for us is, of course, machine learning. So also machine learning, we developed this by ourselves. It's the same as for Vision. And machine learning is also a next step you can use directly in a machine, because we have the inference machine for all the different networks are running really in our real time. And you can use this out of the PLC. So again, this is very interesting also for every machine builder, because Vision and machine learning should be part of the application in the future. And of course, data collection is integrated, so you can use the standard tools for data collect. The only thing which we are not doing for machine learning is this learning algorithms. So machine learning, this learning of networks, it's outside. And last but not least, we are also next year starting with cloud-based engineering. So we want to have more and more engineering in a virtual machine in the cloud so that everyone can use this. And of course, also the build processes, maybe also a Git server in the cloud can be used.
Okay. Yeah, well, that's a lot of things that we can actually, that we see are coming already. Well, yeah, I mean, well, who knows, maybe in the next, in one of the next versions of TwinCAT, we will have the learning algorithm within TwinCAT. No, maybe not. I think the inference part of it is the most important, because the learning itself, actually you do it on dedicated machines with the respective GPUs. So I think that might not be really the most, let's say, urgent functionality that we require in TwinCAT.
Not urgent, but maybe in the future.
We don't know, we see, and what we can see with TwinCAT actually is that functionalities, disciplines, so real disciplines within automation, but also within data science, as we just see here, or vision, they are actually merging into one single platform and can be executed on, well, one computer. So it really does make sense to provide industrial PCs with, well, single, dual, quad, octa-cores, or even multi-cores. So I think it goes up to
60 cores.
So 60 cores. That should well, that should do the job for most applications, I think. Yeah.
Yeah, of course, you need the performance to run all these different things on one platform.
Yeah, and you can clearly within TwinCAT, I think. Is it possible to allocate a specific task, vision task, machine learning task, or SPS task to a specific core, so it cannot be used by Windows anymore?
Yes. So we have a core isolation, which means if you have really 40 or 60 cores, you can really say, okay, you need 2 cores for the operating system, so for Windows maybe, and the rest of the cores can be used by different tasks. So you have 10 tasks for vision, maybe a few tasks for motion control, and 1 task for safety or something else.
Okay, so that means a robust platform. Okay, now Peter and Jakob, looking into the future with what Josef just presented. Well, let's start with Jakob. Which one of these disciplines might make sense to you? Might make sense for you to integrate into maybe your next machine, your next project? What are you looking most forward to?
Well, the thing with TwinCAT is that it's just so much new stuff coming up. So initially I thought I wanted to learn everything, but I realized I have a hard time catching up on all the stuff that Beckhoff puts out. But you talked about vision, and this is actually something we're using here at Dry Face Patterning, and we're using the vision camera. Previously, we had a separate vision system, so you had to have a separate operator panel to control the vision system. Now we have everything integrated into our TwinCAT software, and this is really, it's nice for many reasons. I mean, the operator, of course, really likes this because now he has just one display. We're using the TwinCAT HMI, so he has everything in this modern and nice display to look at it. But it also gives me, as a developer, the full control of the vision. I mean, everything is done for the people that have started working with Beckhoff Vision. Everything is done in PLC code. So for me, this gives me total control. So I just look forward to work more with this and just see where this vision will go.
Okay. So it's actually quite scary to see that a software engineer actually is getting overwhelmed by all these functionalities within TwinCAT. Excellent. Thank you for that. And thank you for your honesty, Jakob. Okay, Peter, what would you say is, well, the innovation, or let's say the functionality within TwinCAT that you are looking for into the future?
Well, certainly I would say that TwinCAT 3 is already future. I mean, compared to many other platforms. I would just include one thing. I was recently beaten up by two groups at LinkedIn after I published an article. One, those who are saying that I am too progressive in my thinking, and the others who are saying that I'm too little progressive. I think what TwinCAT 3 and Beckhoff in general does is that it is walking this thin line of non-destructive innovation. So it's very because it respects the tradition, and at the same time it brings a lot of new possibilities. And what I'm looking for is certainly machine learning will be interesting. Vision, we have to try it out, but it is very exciting technology. I think there is a lot of possibilities in analyzing, and so we can collect a lot of data from Beckhoff PLCs, but there is some work to be done on the data analysis. So these are the things that I wait.
Okay, thank you very much. Well, there is one, I think, other aspect of TwinCAT that maybe you will be looking for, Jakob and Peter, but everyone using it right now, and maybe it's going to be what's going to unlock your interest and going forward with a new platform such as TwinCAT. What is it? Yeah, what is it, Josef?
Yes, of course, this is cloud. So we were starting, of course, with cloud. We also have, of course, edge devices, and also, of course, operating system which are good for edges, so which can execute container applications. So this is a way we are going, of course. We have this cloud-based engineering, so from the engineering from the laptop directly transferred to the cloud so that you can use it with every browser, so you do not need a special installation for this. And of course, the problem is there a time when we cannot sell a standard PLC, PC-based PLC, because all the things are running in the cloud. So I think this is not possible. So we will see more and more things running in the cloud, so configuration, recipe management, and so on. But I think we need a hardware-based cloud, hardware-based PLC, and this is more and more a PC.
Yeah. Well, I mean, so you clearly don't see the execution of the code too much in the cloud. That's going to be locally made on the computer, on the industrial computer, that of course needs to be robust. Yeah. But when it comes to engineering, you do see that this is a part that is going to, well, shift into the cloud and well, be enabling actually suppliers of software to unlock and release quicker new features that can then be used by, well, the users of the software.
Yes. We see this. Yeah.
Very good. Well, we're coming to an end. We have 30 seconds left. We are just in time. This year is about being, well, deterministic, and that's what we're going to be. So we're going to try to end this session at exactly 13:30. And I would like to thank Peter. I would like to thank Jakob. And I would like to thank Josef for being here. With this being said, have a nice rest of the SPS Connect. Bye-bye.